Here we are on the last part of lesson 6.2, estimating solutions of linear systems of equations by inspection. Remember, inspecting it by meaning looking at it, the system. Okay, remember the key concept is that the solution to the system of equations is the point of intersection of the lines. Okay, and if we take a look, we're on infinitely many solutions. All right, the word infinitely means, you know, it goes on forever. So there's infinitely many, meaning there's an infinite amount of solutions. If we look at the graph, though, I'm noticing there's only one line on it. So that's interesting. We'll have to figure this out. Well, let's look at our system of equations, the two equations. We have 2y equals 2x plus 4. And then we have y equals x plus 2. And we know that we have to check the slopes and the y-intercepts, just like we did in the no solution and one solution. We know that one solution, they have to have different slopes, and that's why they intersect at one point. No solution means there's no point of intersection, right? They're parallel, so the slopes are the same. That's why they're never going to cross, because they're sloping at the same rate. But wait, this isn't even in slope-intercept form. So let's turn this to slope-intercept form. Remember, we did a short lesson on that. We want to get y by itself, so we have to divide by 2, divide each term by 2. Okay. And so the first equation would read y equals x plus 2, right? Because we divide 2 divided by 2, that cancels out and you're just left with y. 2 divided by 2 is 1, so you're just left with x. And then 4 divided by 2 is 2. Okay, so this is the same equation as equation number. Wait a second. So when we rearrange this equation in slope-intercept form, it's y equals x plus 2. Well, it's the same thing as our second equation. So actually, these two equations are the same thing, which is why it's one line. Because if it's the same line, then the first equation, sorry, I'm trying to get a marker. The first equation is this line, but the second equation, right? It's like the line is on top of, the lines are on top of each other. It's the same line. That's why we need to make sure that we have both equations in slope-intercept form. And that's why there's infinitely many solutions, because look, if the lines are is on top of the other, that means that there's an infinite amount of solutions. The whole line is all the solutions, because if it's the two lines are on top of each other when you graph them, the points of intersection are infinite. It's the same line. It's all points of intersection. The whole line are points of intersection. So infinitely many solutions means there's infinite solutions and they are the same line.